Hi everyone, my name is Agedo Sapolojisaya, also known as Dr. Proton, and I shall take you through this elaborative course on chemistry. Now, without wasting time, what is chemistry? Simply put, chemistry is the study of matter in terms of its properties, composition, and uses. In other words, chemistry studies the changes that matter undergoes. These changes could either be physical or chemical changes. Let's briefly talk about each of them. A physical change is one that can be reversed because no new substances are formed. This is also because there is no obvious gain or loss of energy. An example of a physical change is the freezing of ice cream, the melting of ice to water, the evaporation of liquid from a mixture, and even the dissolution of salt in water. In each of these examples, we observe that the change can be reversed, such as the freezing of ice cream, which can be melted back to liquid ice cream, which also means that no new substance is formed. A chemical change is just the opposite of a physical change. So, can you define it yourself? I'm sure you're a smart student. Well, a chemical change is one that cannot be reversed because it leads to the formation of a new substance. Examples of chemical changes include the burning of wood to ashes. Of course, ashes cannot be reversed to wood, can it? Another example of a chemical change is the reaction of an acid and base to form salt and water. This is a neutralization reaction. As we said earlier, chemistry is the study of matter. As you already know, matter is anything that has mass and that can occupy space. It could be a deck of playing cards, an airplane, or a basketball. Matter is said to have three states, and they are solid, liquid, and gas. How can we differentiate these states? Well, we simply say that a solid has a definite shape and a definite volume. A liquid has a definite volume but no definite shape. For example, water has no shape, it assumes the shape of its container, and a gas has neither a definite volume nor a definite shape. Easy, right? Matter is also made up of particles. These particles may be atoms, molecules, or ions. Atoms are the basic building block of ordinary matter. An atom comprises subatomic particles such as protons, which have a positive charge, electrons with a negative charge, and neutrons with no charge. A combination of two or more atoms that are linked or connected together by a chemical bond forms a molecule. Now, when you look at an oxygen molecule, O2, you can see that a single molecule of oxygen has or contains two oxygen atoms. Therefore, the atomicity of oxygen is 2. This means that the atomicity of a molecule is the number of atoms it contains. Thus, the atomicity of sulfur is 8. As sulfur is written as S8, the atomicity of ozone is 3, as ozone is written as O3, and the atomicity of phosphorus is 4, as phosphorus is written as P4. Did you know that the shape of a sulfur molecule is like that of a crown? Well, now you do. In addition to our knowledge, we have ions. An ion is a charged atom or molecule. We have positive ions, which are called cations, and negative ions, which are called anions. Certain species also exist that contain both positive and negative ions, that is, that contains both cations and anions. Such species are called zwitterions. Atoms are only neutral if they contain equal number of protons and electrons, that is, positive and negative subatomic particles. A cation results when protons exceed the electrons, whereas an anion or negative ion results when the electrons exceed the protons. The magnitude of the charge indicates the excess. This means that if an atom has a charge of -3, it suggests that this atom, which have now become an ion, has electrons that exceed the protons by 3, while a charge of +2 means that protons exceed the charge by 2. Consider the table below as a case study. We have our element or ion, the number of protons, the number of neutrons, and the number of electrons. Now, the first ion is the sodium ion, Na+, which has a mass number of 23 and an atomic number of 11. Its proton number, which is equal to its atomic number, is 11. The number of neutrons can be calculated by subtracting the proton number from the mass number. As a result, we have 23 minus 11 is equal to 12. And the number of electrons is supposed to balance the number of protons, and it's supposed to be 11. But as you can see, sodium is a positive ion with a charge of +1, which means it has lost 1 electron, or it has an excess proton. So the number of electrons become 10. The second species, oxygen, 2-, which has a mass number of 16 and an atomic number of 8. Since atomic number equals proton number, its number of protons is 8. Its number of neutrons becomes the mass number 16 minus the proton number 8 equals 8. Now what about its number of neutrons, or its number of electrons rather? Now oxygen is supposed to have 8 electrons, but as you can see, this is oxygen ion, and the charge 2- means that though it is supposed to have 8 electrons, we have excess 2 electrons. As a result, the number of electrons becomes 10. The third species is aluminium 3+, with a mass number of 27 and an atomic number of 13. Its proton number is equal to its atomic number, so the number of protons is 13. The number of neutrons is the mass number 27 minus the proton number 13 is equal to 14. Now what about the number of electrons? Aluminium should have an electron number corresponding to its number of protons, which is 13. But here you will notice that aluminium ion has a charge of +3. This means that we have 3 excess protons, or 3 electrons out of the 13 have been lost. So the number of electrons for Al3+ is also 10. Now let's take the last atom, chlorine. Now this is not chlorine ion, it is chlorine atom because it has no charge. Chlorine has an atomic mass of 35 and an atomic number of 17. Correspondingly, its number of protons is 17. Its number of neutrons is 35 minus 17 equals 18. And its number of electrons, because chlorine is uncharged, is equal to its number of protons and is also 17. Please note that the mass number of an atom is the sum of its proton and neutron. So, mass number equals P plus N, where M equals mass number, P equals proton number or atomic number, and N equals neutron number. You got that right? Observing the table above, you will notice that the sodium, oxygen, and aluminum ions contain the same number of electrons. So, they are said to be isoelectronic. Moreover, before now, you must have heard of an element. You may have wondered what a compound and even what a mixture is. Well, an element is a substance that cannot be split into simpler units by an ordinary chemical process. Examples of elements are hydrogen, sodium, and even calcium. A combination of 2 or more elements forms a compound. An example of a compound is sodium hydride, NaH. Another is calcium chloride, CaCl2, and even calcium iodide. A compound is formed as a result of a chemical combination between 2 or more elements. So it means that a compound cannot be split or separated by an ordinary chemical process. On the other hand, a mixture contains 2 or more substances that are not chemically combined together. Thus, it is possible to separate a mixture by various separation techniques. It is also important to note that elements and compounds are pure substances, but when these elements and compounds contain impurities, they become mixtures. So, sodium chloride is a compound, but impure sodium chloride is a mixture. Other examples of mixtures are blood and bronze. So, how do we separate mixtures? Well, we separate mixtures by means of separation techniques. There are several separation techniques mentioned in standard chemistry textbooks, but I will talk about the important ones here. Sieving is the first one we will take. Sieving is a separation technique that is used to separate a mixture of solids that have different particle sizes. We use sieving to separate a mixture of sand and stone. Secondly, sublimation is a technique that is used to separate a substance that can change from solid directly to gas from other solids. Substances that can sublime or substances that can change from solid directly to gas without passing through the liquid phase are called sublimates. And these substances include iodine crystals, dry ice or solid CO2, ammonium chloride, camphor, and naphthalene. The third separation technique is centrifugation. Centrifugation is used to isolate a mixture of insoluble solid and liquid by spinning the mixture. Centrifugation is a technique used to separate the various components of blood. We also have crystallization. This is used to recover a pure sample of a substance from its solution. It is used when the purity of a substance is concerned, and that is why for manufacture of drugs in pharmaceutical companies, crystallization is a very important technique to produce pure drugs. Penultimately, we have distillation. Distillation is used to separate two or more miscible liquids that are far apart boiling points. Why must they have far apart boiling points? Because distillation is quite different from fractional distillation. Now, in fractional distillation, we separate two or more miscible liquids that this time have close boiling points. For example, in the oil and gas industry, the separation of petroleum into its several components is by fractional distillation. The separating funnel method, a method common to most of us, is usually used to separate two or more liquids that cannot mix with each other. For example, we use the separating funnel to separate a mixture of kerosene and water or petrol and water. Lastly, chromatography is used to separate substances based on their rates or movements or migration. It is used to separate amino acids, colored substances like ink, and even chlorophyll. And that's how we come to the end of the introductory aspect of chemistry.